Hello everyone, welcome to Step a Day. This is the first question. So in this video we're only going to be doing part I only, and then next video we'll do I, A, and then I, B. Alright, so let's get straight into it. So we have part I. So it says for n equals 1, 2, 3, and 4, these functions p of n of x and q of n of x are defined. So p of n looks rather nasty, but q of n doesn't look as bad, and they don't hold for the case of x equals minus 1. And it's asking us to prove that, or show that p n of x is equal to q n of x, so they're identical for n equals 1, 2, and 3. And then the final part is to show that it does not hold in the case that n equals 4. So let's get straight into it. So let's try for the case of n equals 1. So we need to find p1 of x. So it's x plus 1 to the power of 2n, which is 2 times 1, which is 2, minus, and then 2n plus 1. So 2 times 1, which is 2, 2 plus 1, which is 3. So 3 times by x, all of that times by that whole bracket, which is the power of n minus 1. So that is to the power of 1 minus 1, which is 0. Anything to the power of 0 is just 1. So we can just leave it like this. And we expand this out now, and it gives us x squared plus 2x plus 1 minus 3x, which is x squared minus x plus 1, right? And then let's try for q1 of x. So we sub in n equals 1, so x to the power of 2n plus 1, so that's 2 times 1 plus 1, which is cubed, so x cubed plus 1 over x plus 1. And since it's literally saying that it's equivalent, we can use a little inspection method and just assume that they should give the same results. Assume that you have done nothing wrong for calculating p1 of x, right? So we can just assume that. Of course you can use polynomial division, but with step you need to be very careful on time. So we're just going to assume that when you expand this with this, it gives you x cubed plus 1, right? Okay, so, and then we do our statement, therefore p1 of x is equivalent to q1 of x, right? So that's for n equals 1. Now we try n equals 2, so n equals 2. So p2 of x, let's find that out. So it's x plus 1 again, to the power of 2n, so 2 times 2, which is 4, minus, and then 2n plus 1, so that's 2 times 2 plus 1, which is 5, x, all of that times by that bracket to the power of n minus 1. So that's to the power of 2 minus 1, which is just 1, which is just itself. So x squared plus x plus 1. Now let's use Pascal's triangle. So you should know this, but this is how it starts. You put the 1s on the outside and then you sum the adjacent pairs. So 3, 3, 1, 4. So you add these and then you add this, so that's 6. Add these, 4, and you put the 1s on the outside. It goes from 0, 1, 2 in the middle, 3 in the middle, and you just keep on adding. So we only need up to here because it's x to the 4, right? So now we can expand x plus 1 to the power of 4. So this is the x to the 4th coefficient, x to the x cubed coefficient, x squared coefficient, x, and then the constant coefficient, right? So using this binomial expansion, because it's just x plus 1, that's easy. We don't have to actually do anything else. We just need these. So we can just write x to the 4 plus 4x cubed plus 6x squared plus 4x plus 1, and then minus all of this. So let's expand this with this. So minus 5x cubed minus 5x times x minus 5x squared minus 5x times 1 is minus 5x. And then if you clean that up, that gives us x to the 4x cubed minus 5x cubed, so minus x cubed. 6x squared minus 5x squared is plus x squared. 4x minus 5x is minus x plus 1, right? So that's our p of 2. Now let's calculate our q of 2, because remember we have to show that they're equivalent. So q of 2 of x is x to the 2 times 2 plus 1, so x to the 5 plus 1 over x plus 1, right, as you can see here. So we can just use the same trick. we can just assume, of course, hopefully, that we haven't done any algebra wrong, that it hopefully expands to give us this. Of course, you can use polynomial division, as I said before, but that takes long. And then you can say, therefore, P2 of x is equivalent to Q2 of x, right? Okay, so we've proved it for 1 and 2. Now we need to prove it for n equals 3. So let's start off with P3 of x. Let's see what that gives us. So n equals 3. So it's x plus 1 to the 2n. So x plus 1, and then 3 times 2, which is 6, minus 2n plus 1. So n is 3, n equals 3. That's why it's that there. So 2n plus 1 would be 7. 7x. And then that whole bracket is x squared plus x plus 1 to the power of n minus 1. So 3 minus 1, which is squared. Okay, so let's focus on this bracket first. So x plus 1 to the 6. So we just have to carry on our Pascal triangle. So put the ones on the outside. Add these two, then 5, and then 1. If you notice, these are actually symmetrical. But yeah, it's still good to work them out. So 1 plus 5 is 6, 15, 20, 15, 6, 1. Right, we just need x plus 1 to the 6 anyway. And because this is just x and then this is 1, we don't actually have to do hard binomial expansion. So let's do it. So this is the x to the 6 term. So it's x to the 6 plus, 6x to the 5 plus 15x to the 4 plus 20x cubed plus 15x squared plus 6x plus 1, right? So that's that bracket done. But now we have this triple bracket. It's only squared, so it's not too bad. So we'll have x squared plus x plus 1 times by itself. So we'll start off with this term, so it's x to the 4 plus x cubed plus x squared, and now this one, x cubed plus x squared plus x, and then now this term, x squared plus x plus 1. Now we can group together like terms, so these. So it's x to the 4 plus 2x cubed plus 3x squared plus 2x plus 1, right? And that's being times out by minus 7x. So let's just put that here. And now let's expand it. So minus 7x to the 5. So we're just timesing minus 7x by what we just got. So minus 7x to the 5 minus 14x to the 4 minus 21x cubed minus 14x minus 7x, right? So now we need to add it onto this equation because we already have that expanded now. That was the result, and then now this is the result. So let's add it. So when we add it, we get, so the x to the 6 stay the same, x to the 6, and then we have 6x to the 5 minus 7x to the 5, so that's minus x to the 5. 15x to the 4 minus 14x to the 4 is plus x to the 4. 20x cubed minus 21x cubed is minus x cubed. 15x squared minus, that's supposed to be 14x squared, is plus x squared. 6x minus 7x is minus x. And then plus 1 plus nothing, just plus 1. So that's our expression, okay? Our final expression for P3 of x. So now we need to find Q3 of x and then use literally just a similar trick that we have been doing. So Q3 of x, so it's x to the 2n plus 1, so n equals 3. So 2n plus 1 is 7 plus 1, and then that's all over x plus 1. And we can just do the same thing because we know we need this denominator to cancel, so we can just assume by inspection that it gives us this nasty bracket. If we've done our algebra right, x cubed plus x squared minus x plus 1, and then these cancel, so you can just say Therefore, Q3 of x is equivalent to P3 of x as required, right? So that's like the first part of the question. Now we have to say that it does not hold true, or does not hold in the case for n equals 4. So Q4 of x is not equivalent to P4 of x. So now there's a little trick we can do. So we still sub in, so let's start with P of 4 of x. Let's see what we get. So P4 of x. So when n equals 4, so it's x plus 1 to the power of 2n. So 2 times 4, which is 8, right? Minus, so 2n plus 1, so that's 9. So 9, and then it's 9x. And then that whole bracket, and then that whole bracket to the power of n minus 1, so 4 minus 1, so x squared plus x plus 1 cubed, right? Yeah, okay, so that's P4 of x, and then I'm going to show you a little trick. So let's just find out Q4 of x. What does that give you? That gives you x to the 2n plus 1, so it'd be x to the 9 plus 1 over x plus 1. So of course, proving that they're equivalent, we obviously have to expand everything out and show that it's the same. But if we're proving that they're not equivalent, we can just sub in some value of x. And if they're not equivalent, then of course it does not hold. But to show that it does hold for each case, you have to algebraically show them. So for example, let's try x equals 0. So P4 is 0. So that's 0 plus 1 to the power of 8, which is 1, minus 9 times all of that, which is just 0. So it's just 1. And then Q4 of 0 is 0 to the 9 plus 1. So just 1 over 0 plus 1, which is 1. Okay, so it holds in that case, but it probably doesn't hold for every case, because we're proving that it does not. Okay, so let's sub in 1. So we have 1 plus 1, which is 2 to the power of 8, which is 256, minus 9 times 1, so just minus 9, times by this whole bracket to the power of 3. So that's 1 plus 1 plus 1, which is 3, and that's all cubed. 3 cubed is 27, and then we need 27 times 9. Well, 27 times 10 is 270. We need to take 127 away, so that gives us 243. So 256 minus 243 is 13. So we need this to be equivalent to 13 to show it does hold, but let's just see. So now let's sub x as 1 into Q4 of x. So 1 to the power of 9 is 1, 1 plus 1 is 2, 2 over 1 plus 1 is 2, so just 1. So as 13 does not equal to 1, Q4 is not of x is not equivalent to P4 of x as required. Yeah, and then we'll do part 2 in the next video. Thank you for listening. Hello everyone, we are back with the part 2. So following on from part 1, we start with IIA. So let's just get straight into it. So it says using the results from part I. So if you haven't watched the video of the first part, you should definitely look at it, but if not, it's fine. We can just use these results for these functions. So it says express this as a product of two factors, neither of which is 1. Right, so we can see this equivalence to Qn of x, right? Because look, it's 300 cubed plus 1 over 301. And then our Qn of x is x to 2n plus 1 plus 1 over x plus 1. So you see this is our x, right? So our x is 300, and obviously look at the denominator, 301, x plus 1. So our x is definitely that. And then our 2n plus 1 is this power. So 2n plus 1 equals 3, therefore n equals 1. And it's saying using results, so let's just use what we have and put it into Pn of x, right? So our n is 1, so P1 of x. and we need this as the product of two factors. So let's just see what we get when we put it in. Well, our x is actually 300, so let's just do that. So it's x plus 1 to the power of 2n, so it's 301 to the power of 2n, which is squared, minus 2n plus 1, so that's just 3, times x, which is 300, and that is all multiplied by that bracket to the power of n minus 1, so 1 minus 1, which is 0, so that just evaluates a 1. So this is our final expression, so it's 301 squared, and we need this as a product of two factors, so let's just times that, so that's minus 900, and minus 900 is actually 30 squared, right? So remember, so we need to remember that a squared minus b squared, this is a thing called difference of two squares, is a plus b, a minus b, right? So you see these are two factors, right? For example, so we can rewrite this as this. So this is our a and this is our b, right? So it's 301 a, so a, b, so a plus b, so 301 plus 30, and then times by 301 minus 30. So it's 331 times by 271. So those are two factors as required, right? So now we go on to B. So this one's a little bit more tough, but let's just write our Qn of x again. Is x to the 2n plus 1 over x plus 1. And then we have 7 to the 49 plus 1 over 7 to the 7 plus 1, right? So we can clearly see our x is 7 to the 7, right? Straight away, because the denominators match. But this is not the same thing as that, because our x is not 7, it's 7 to the 7. So we need to take out a factor of 7 to the 7. So let's look at the numerator. 7 to the 7, because that's now our x, right? Now we need to get to 49. The way we do that is we need to do 7 times something to get 49, which is just 7, because you multiply these indices, right? So 7 to the power of 7, all to the power of 7, plus 1 over 7 to the 7 plus 1. So now we can use this to match it. So our 2n plus 1 is now 7, so our n is clearly 3. Okay, so now we have this. Our x is 7 to the power of 7, n equals 3. Now let's use Pn of x. So Pn, so P3 of x is 7 to the 7. Let's sub in and see what we get. So we have x plus 1. So that's 7 to the 7 plus 1 to the power of 2n. So 2n is 6 minus 2n plus 1. So 2 times 3 plus 1 is 7. And then it's 7 times x, so times 7 to the 7, that whole bracket is x squared plus x plus 1, so it's 7 to the 7 squared, well that's just 7 to the 14, so we can just simplify that, plus 7 to the 7 plus 1, all to the power of n minus 1, and our n is 3, so it's squared, right? Now, I'm guessing using the same logic, we have to find the difference of two squares. So let's sort this bracket out first. If you want this all as a square, we can take out 7 to the 7 plus 1 cubed and then square all of that, right? Because we want it in the form a squared minus b squared, so we can use the same thing as before. The reason we can do this is because 3 times 2 is 6, and that's just the index law. You can times together the powers, right? And then we can actually make this a little bit simpler. So that's 7 to the 1. You add the powers, so that becomes minus 7 to the 8, and then all of this plus 7 to the 7 plus 1 all squared. Well, we have a square here, but this is still here. So the way we do this is we also take out something times by 2 to give us 8, so that is 4. So if we look here, have that all squared, it's because when you square it, this becomes 4 times 2, which is 8, and then, which is what we had here, and then you square this, you also square the whole bracket, which is what we had here, right? So, okay, so now we have a difference of 2 squares again, minus, and then 7 to the 7 plus 1 cubed all squared. So our a is 7 to the 7 plus 1 cubed, and our b is 7 to the 4, 7 to the 14 plus 7 to the 7 plus 1, right? So now remember, we can write this as a plus b, a minus b. So this is a, this is b. So a plus b is 7 to the 7 plus 1 cubed plus 7 to the 4, 7 to the 14 plus 7 to the 7 plus 1. All of that times by, I know I put on a new row, but it's all being times by a minus b. So 7 to the 7 plus 1 cubed minus, and then b, 7 to the 4, 7 to the 14 plus 7 to the 7 plus 1. So these are being times by each other. So these are the two factors, and we're told not to calculate them explicitly because there's a lot of 7 to the 7s, for example. And yeah, that's our final answer. So as required, that's it. Well, thank you for staying to the end, and have a good day.